Hello, welcome to lesson 3 on polynomials. We're going to really kind of unleash the power of the last two lessons to explore some very cool stuff today. So here's a nice little function. I'm going to explore what's going on there. So what could I do with it? I could factorize it. I could figure out what can go in here. I mean, x squared is going to come from an x times an x. Negative 3, so I'm thinking I've probably got either a plus 1 and a minus 3 or a minus 1 and a plus 3. To make that positive, it's going to be x plus 3 and x minus 1. So that was fun. How does that help me? Well, let's try and explore what's going on here. I'm going to think about this as a kind of function of y equals that equation there. So I'm going to try and graph what are the y numbers for different x numbers. And some of the most interesting ones straight away you can see here. If I put in x equals 1, I've got 1 take away 1 is 0 there. So my whole answer for y is going to be 0 when x equals 1. So that's this coordinate here, x equals 1, y equals 0. Similarly, if I put into there x equals negative 3, whatever happens here, it's still going to give me the answer 0. So similarly, when x equals negative 3, I'm going to have y equals 0. And because it's an x squared graph, and I have an idea that I know what x squared graphs do, so x squared graphs generally look like this. Minus x squared graphs look like this. So if you're not sure, okay, the positive x squared graph is a happy, positive smiley face. The negative x squared graph is unhappy, so upside down smile. There we go. So I can draw this graph. And this is brilliant. This gives me an idea. This gives me an idea of, for any value that I put in for x, what's y going to be? Say x is like 10, y is going to be probably, I don't know, like big number over here, 100 or something. So what else can I find out? It'll be interesting to see what happens here. Where do I cross the axis? Well, that's quite an easy one. If I put in x equals 0, that's what happens here. So this is where x is 1, x is 2, x is 0 is the y-intercept. So x is 0, 0, 0, negative 3. There we go. So the y-intercept is negative 3, and I found it by putting in x equals 0, coordinates 0, negative 3. I'm going to try and find out where the bottom is. Is it here, like it kind of looks like I've drawn? Or is the bottom maybe off to the side slightly? So the best way to do that is to use tool number 2 from this week. We're going to complete the square on that. We want it to look like x plus something or minus something, all squared, and then plus or minus something else. So it's going to be x plus 1 all squared, because when you expand that out, you get x squared plus 2x plus 1. And it's going to be minus 4 to make it match up to this. You can expand this out and check that I've got it right. Okay. Well, this is really interesting. Think about this all squared bit here, okay? Let's just put some numbers in there randomly. So at x equals 0, what do I get? I've got 0 plus 1 is 1. 1 squared is 1. Take away 4, I've got negative 3. We already knew that. That was there. Let's put in x equals 1. What do I get when x equals 1? I've got 1 plus 1 is 2. 2 squared is 4. Take away 4 and I get 0, and we already knew that as well. And you can put in other numbers. Let's just try x equals negative 2 just for a change. Negative 2 plus 1 is negative 1. Squared is 1. Take away 4 is going to be negative 3. So I've got this coordinate here, okay, which is 2 and negative 3. Kind of matches that. So I'm thinking that my graph really is going to have a bottom somewhere sort of in between these 2 points that match the same height. Easy way of checking, think about this. This bit is something squared. So whatever number is inside here, the answer is always positive, right? Because see, minus 1 squared is 1, minus 10 squared is plus 100, negative 3 squared is positive 9, minus times minus makes plus. So this bit always gives me a positive answer. And what that means is the smallest possible answer from this function, the minimum point of this function, okay, is going to be where? Is going to be at x equals -1. Why? Because at x equals -1, I've got -1 plus 1 squared, take away 4. This bit is 0 squared, take away 4, which is going to be -4. But I can't ever get anything less than 0 squared, because whatever number in here, if it's not 0, then basically when I square it, I'm going to get a positive number and I'm going to get a bigger answer. So my minimum is going to happen here at x equals -1, which you can see straight away from there. Okay, and the answer is going to be -4. So here, I've got my minimum point. My minimum point is at -1, 4. And when I'm sketching graphs, it's really good to label the axis crossing points and the minimum or the maximum turning point. Okay, that is really interesting stuff. So we could ask, what's the point of the quadratic formula? Does that formula bring anything to the party? And the answer is yes. To think about why, we're going to look at this graph here, and I'm going to draw some friends for it. So here is the graph that I have, which has its bottom point at -1, 4. And I'm going to draw it a friend. Sorry, there you go. I'm going to draw this graph a friend, sort of up here. This graph, let's make it be 10 points higher. So that was -4. This has gone up 10. So this is going to be at 6 on the y-axis, -1, 6. So I've gone up by 10 places. Now, first graph had two solutions. They were here at x equals 1 and x equals -3. Two roots, two solutions. This graph has none. It's very sad. This graph doesn't cross the x-axis anywhere, so it doesn't have any solutions, it doesn't have any roots. And what I'm going to draw just now is a very special friend for these guys. This special friend just touches the axis like that. And this one, this is going to be at -1. As you can see, these are always at -1 if I'm just going up and down. Okay, so this one, -1 and 0. So it has its roots or solutions are both, I mean, there used to be two of them and they've sort of come together. So they're both here. There's only one unique root or solution. There's two that are both the same. And it just touches and has one solution. What has this got to do with the formula? Well, let's hit this one, my original equation, with the formula. So that was -b plus or minus the square root of b squared minus 4ac all over 2a. So a is 1, b is 2, c is -3. So -2 plus or minus the square root of 2 squared minus 4 times 1 times -3 all over 2 times 1, which is going to give me... okay, let's just kind of jump a few steps because I'm running out of room, but you can work it out properly in full. No, let's not jump actually, let's just go down to here. So that's going to give me -2 plus or minus the square root of 4 plus 12 all over 2, which is going to give me -2 plus or minus square root of 16 is 4, right? So 4, and they're both over 2. So I've got basically -1 plus or minus 2, which is either equal to -3 or it's equal to +1, which were, of course, the solutions that we already had here. But look at what happened. Why do I have two possible different solutions here? Sorry, why do I have two possible different solutions here? Well, it's because I had plus or minus 2. It's because I had plus or minus 4 over 2. It's because I had plus or minus the square root of b squared minus 4ac, right? So this number in here, this is very special, and we're going to call this the discriminant. So this is something well worth noting down, okay? You need to remember this, you need to be able to use this. Discriminant, okay? Discriminant. So the discriminant is the bit that we call b squared minus 4ac. It's the bit that lives in the square root sign there, okay? And what that means is, if this part here is a number, a positive number, then I end up with plus or minus something and then two different answers. If this part in here is 0, I end up with plus or minus 0, which does nothing. So I end up with just the one answer. So that's this situation here. And if this part in here, if the b squared minus 4ac is negative, well, you try square rooting a negative number on a calculator. See what you get. Okay, it's going to tell you error. It cannot be done. Okay, so basically, if this bit is a negative number, you're not going to have any solutions. And so this discriminant part of the formula is very special, and it lets me tell you straight away, does it look like this with two solutions? Does it look like this with just one solution? Or does it look like this with no solutions, no roots? Okay, so let's write it down. B squared minus 4ac is greater than 0. Then we have two different roots or solutions. B squared minus 4ac equals 0. We have two what we call repeated roots, or sometimes two identical roots or solutions, same thing. Okay, so just different words that mean the same thing. And if b squared minus 4ac is less than 0, then what does that mean is going to happen? We're going to have no solutions. And this is something that you'll be asked to do and to use in exams quite regularly. So you have to make sure you understand how to do it and how to use it. Just to prove that it's right, we did this bit here, and we did b squared minus 4ac for this function here, and we got the number 16 in here, which is a positive number, and that's why we had two answers. This one here, which has gone up by 10, is going to be my same function, but it's gone up by 10. So let me just label it up. This one here has gone up by 10. So my function used to be this, x squared plus 2x minus 3, x squared plus 2x minus 3. Now it's plus 10. It's gone up by 10. All the answers have got bigger by 10. The y equals the same, but gone up by 10. Okay, so that's going to be x squared plus 2x plus 7. Right, so what do we know? A is 1, B is 2, C is 7. Let's work it out then. B squared minus 4ac is going to be 2 squared minus 4 times 1 times 7, which is going to be, 4, take away 28, which is negative 24. Therefore, negative 24, therefore, no solutions, because it's less than 0. You should probably say that. Okay, and similarly, for this very special one, it was minus 4, so it's gone up by 4. So this very special one will have the formula x squared plus 2x plus 1. And if you work it out for that, I've got b squared minus 4ac is going to be 2 squared minus 4 times 1 times 1, which is going to be 0. Therefore, what you would say is one of these two repeated roots or two identical solutions. It looks like that, just touches in one place. Both the roots are identical, they're repeated, they're in the same place. Okay, and why do we say repeated roots and two repeated roots? Well, if you factorize this, you'll get x plus 1, and you'll get x plus 1 again. So why do I not say one solution? Well, kind of, there's two solutions, but they happen to be identical. They happen to be the same. Both of these brackets give me x equals minus 1, and that one also gives me x equals minus 1. I have two identical solutions or two repeated roots. There we go.